Here, let's continue. Okay, just now we covered the individual body and we defined the fundamental equation for rotating body. Now let's say we have two gear, gear B, gear C. They have a contact point at A, right? So the contact point A for body B is meeting with contact point A, comma, of body C. And if B rotate clockwise, it will push the A rotating anti-clockwise. Yeah. Okay, so the point in the contact move along different circular path means one is clockwise, one is anti-clockwise. Okay, B in the clockwise, C in the anti-clockwise. Then we break the two objects away. We dismantle the two gear and we can draw the velocity vector. Because this is a circular motion or circular path, you know that velocity always 90 degrees to the direction. So VA point down, VA comma for gear C also go down. Yeah. This one happened at the contact point, at the contact point. So you can derive the velocity. What I want to show is the vector diagram for velocity, which is the left hand corner, this one. The velocity go down with the different circular motion, and you can convert from the V, you can change the V become acceleration, because you know that you have AT and AN. AT always follow the direction of your velocity. It is if you look at the gear B, AT go down, and AN always pointing inside the circle. That's why for B, your AN is towards inside to the left. And once you have AN and AT, you can draw resultant pointing towards the left hand side. Same apply for gear C. AT, A comma T, following the velocity direction, which is pointing down straight. However, the A comma N is pointing towards the C. It's not following the B. Yeah? So what is different is the normal component of acceleration. This one I want to highlight. Okay? Acceleration, normal component always pointing inside the circle. Okay, we look in example 1. And you're given a chord. Okay, now chapter 5 question, always you see a reference point, fixed point O with the angle, and you're given R, and you're given a force and give you a velocity or acceleration. And the thing is rotating always in chapter 5. So the chord is wide around a wheel with initially at rest. So we have a velocity before happen at rest. So when the thing at rest, your velocity 0, your angular velocity 0, angular acceleration also 0. When you, that one is typo error, is angle, theta 0. Theta 0 means start from here. And you follow the motion. This is anti-clockwise. This is clockwise. If a force is applied to the cord and give it an acceleration A, you are given acceleration A. Just now in our formula, we have left-hand side. Left-hand side of the formula is A V. On the right-hand side is omega alpha. So you don't confuse. This one is layman term, or the language that communicate with the technician. So A, acceleration here is A, given in the formula for T. So acceleration AT here is in a linear form. Determine as a function of time the angular velocity of the wheel. So you need to find angular velocity, which is omega, and the angular position. Angular position of the line. Angular position means theta. Okay, so you need to start to change your thinking a bit. Rigid body, you no longer see S replaced as theta, V as omega, A as alpha. Okay. So for part A, you need to draw a diagram. So the wheel is on a rotation fixed point through P. So you just call out the equation. A equal to what? Just now, A equal to omega square R, right? You just straight away apply that formula. And then A is given. Omega you need to find. T is in the T form. Okay, so point P, acceleration of this point has both tangent and normal component. So acceleration, same. Velocity, always tangent to the curve. Velocity go down. AN always pointing inside the circle or towards the origin. So you have acceleration in tangent is what is given in the question, because you pull this line in this direction and always tangent to the circle. The chord is always tangent to the circle. So this direction AT is what given in the question. So your AT equal to 4T squared. 4T. So you know that your acceleration you need to convert into rigid body definition, where it's in alpha R. A equal to alpha R. So you put in the parameter R, 0.2. On the right hand side, you follow the question for T. So you rearrange, you move 0.2 to the right. The answer is alpha equal to 20T radian per second square. And it is clockwise. Okay, complete answer for chapter 5, you need to give me direction, whether it's anti-clockwise or clockwise. And it's in radian, radian per second square. In acceleration that you learned in chapter 1 to 3 is meter per second square, which is A, but this is angular, with in rotation, rigid body in alpha. Okay, once we have alpha, you need to find angular velocity, which is omega. So you call out the definition of acceleration. A equal to dv dt. Again, convert A into alpha, V as omega. So alpha equal to omega dt. It's important you give definition of the term alpha equal to d omega dt. So you pull because you need to find the omega. So you rearrange the equation, pull the dt to the left. You get alpha dt d omega, start integration. Alpha you already derived in the previous one. So put in alpha here, because alpha, if you put in alpha, you cannot differentiate completely, because your alpha is 20t, is from 0 to t, And on the right hand side is omega, 0 omega to omega. Why we know we can start with 0 omega? Because the questions say it initially at rest. That's why there's no angular velocity at the start, 0. Okay, the rest is just the derivation of integration. So 20t dt, you get t squared divided by 2. Answer is 10t squared. On the left, you integrate from 0 to t. Answer is omega equal to 10t squared, and it's clockwise. Unit important, huh? Omega is actually velocity. So velocity is meter per second, but this is angular. So meter change to radian. Okay, if you move in the linear, you have meter, but this is a rotation. So rotation, you define displacements as angle. Okay, so this is a first question. So you have alpha and omega already, huh? Alpha and omega already. Alpha and omega already. Then, because you need to know angular position, d theta. So recall definition of omega. Omega equal to d theta dt. Do the same. You need to find theta. So this differentiation equation, move dt to the left, do integration again. Okay, do integration. You start from 0 because it tells you at rest. Okay, and it start at theta equal to 0. U typo error, it should be theta equal to 0. So it start from 0 to theta. And omega dt, you are integrating time and not omega. So dt, so from 0 to time. So you do integration. On the left is theta minus 0. There's a 1 here. Right? 1, you integrate this integration, you get theta, and then you take theta minus 0 on the left. Omega, you just copy from the previous answer. Previous one, you find 10t squared, so put in here. Do integration. This is t cubed divided by 3. So 10 divided by 3 and t cubed. Integrate from 0 to t. So the answer is in radian form. Theta equal to 10 divided by 3 t cubed radian. Okay, so the example 1 is just a revision of the definition, omega, alpha, and then do integration. So this usually is the first step in your test 2 or final exam question. Usually you start with the definition of alpha, omega, then you do integration, and you find in the general form or in the equation form. Then you substitute according to scenario. Okay, so again, this is, you cannot use the equation of constant angular acceleration or the Newton equation because your acceleration is not constant. Okay, now if you understand example 1, example 2 is just another extension of what you learned previously. So you have a wheel there, a motor wheel, and you have two motor there, a two wheel there, one on the top, one at the bottom. So on the top there, you have a small wheel or small rotating body there, A, with a radius of 0.15 meter, and you're given angular acceleration alpha. And below there, you have wheel B with its radius 0.4, and you're given an interest point P. So the motion is quite direct. If you turn A in the clockwise, B will turn in the clockwise. And you have an angular acceleration here. If you turn acceleration here, this one will be slower than the top because it's smaller radius, this one is bigger radius. These are the common logic before you do analysis. So and then you read the information. If pulley A connected to a motor begin to rotate from rest, so means your omega 0, velocity, acceleration all 0. With a constant acceleration alpha given, determine the magnitude of velocity and acceleration of point P on a wheel after the wheel has turned 2 revolutions. Assume transmission belt does not slip. Means no loss of energy and so on. So here 2 revolution means angle. 1 revolution is 2 pi, 2 revolution is 4 pi. Okay, if you read the question, it asks you about velocity after acceleration after. It means you can use, and the acceleration is constant. Acceleration is constant means you can use the equation, the 3 equation that you derived just now. It's like the Newton motion equation, but this one is you can use the angular motion equation. Convert the 3 equation into angular term. Then you look into which one is missing. You look into the 3 equation, there will be one equation that only have one unknown is missing. You can write the 3 equation and then you compare each equation. Okay? It asks you the magnitude of velocity and acceleration. So you take velocity, then you take the velocity equation. V is given or omega is given before start, and before start is all 0. Right? So angular motion, change the angle. 2 revolution is how many radian? Is 2 pi radian, 4 pi radian, 2 revolution, 4 pi. So, or is 12.57 radian. So A turn 12.57 radian. It do not same as B. This is you turn A 2 times. This one not necessary, B not necessary turn 2 times because of different radius. But what is same is the S, the circumference of the circle. Okay, so if you turn 360 degree, you have 1S of this one. You can find the S, right? The circumference of the circle. So it turn 2 times means the distance traveled by A will be translate to B. Then you can check, you can find the angle of the rotation of B. Because the distance rotate 2 times will translate to B. The SA will same as SB here. What is different is the angle. Radius is given. Okay, S equal to R theta. SA will same as SB. So I will just straight away use the formula. Omega square equal to omega O square plus 2AS. So this or theta. So this one is V square equal to V square O plus 2AS. You change the S to theta, change the A into alpha, change to V into omega. Substitute inside the known value. Omega O is start from rest, so 0. Alpha is given 2. Angle is given. You don't know the angle. Angle you know because it start from 0. So angle starting point is 0 actually. So you just press calculator, you get omega A equal to 7 radian per second. So just application of the angular motion equation. And direction important. This one is clockwise positive, following the diagram. Positive. So you know that the velocity of the belt is the same. Right? A, you move at a certain speed, it will translate to belt B, the same speed, velocity. So velocity is the same. So omega r, V equal to omega r. A will same as omega RB. This is the very important linkage between two bodies. Velocity, if you have control by the belt, velocity always translate or transfer to another body. This is a connecting formula. If you miss this one, you cannot do the next steps. So velocity always translate through the belt. Because the question already say, do not slip. Transmission do not slip means velocity transfer to another pulley on another belt, another wheel. Put in all the parameter. On the left, you do A. On the right, you do B. Omega A, you defined previously. R is given in the diagram. Omega B, you don't know. RB, you know. So there's only one unknown with omega B. So answer is 2.7 or 2.65 or 66 radian per second. So once you have the omega, you can do acceleration. Acceleration A you have, you can do B. So acceleration also same, because do not slip, belt do not slip. So acceleration velocity always same. If you're connecting with the belt, velocity magnitude also same because the tangent direction also same. So AT equal to alpha R, A was same as alpha RB. So A is given in the question 2 radian per second square. R is given in the diagram. Alpha B, you don't know. RB is given in the diagram, so there's only one unknown, alpha B. So alpha B equal to 0.750 radian per second square. So careless mistakes always at the unit. Some of you, you forget to put in the unit. Some of you, you write the wrong unit. Okay. So chapter 5, you need to remind yourself you are dealing with alpha, omega, theta. Okay, motion P. It asks you to draw the diagram of motion P. Remember, the question asks you velocity. It do not ask you angular velocity. If you stop at here, you do not answer the question properly. Here, you only get angular velocity and angular acceleration. The question asks you velocity and acceleration. You need to convert angular back to non-angular, means linear motion. So what you do, you go to the diagram. You have APT, you have AN, and this one is circular motion. AN equal to V square over rho. V equal to omega R. AP equal to alpha R. So VP equal to omega R. VP means tangent direction velocity. So WB you defined just now. R is given in diagram. So WB 2.659 multiplied 0.4. You get VB. This is a V velocity here is a chapter 1 to 3 linear motion. It's a linear motion. It's what you can read from your instrument. Your instrument do not give you angular acceleration or velocity. Your instrument give you velocity. Okay. Same. Alpha equal to alpha R. A equal to alpha R. Again, just now Left-hand side of the equation is the linear term with its velocity acceleration. Right-hand side is angular dimension. It's a translation how you communicate with the normal people. Right? You don't talk to normal people angular velocity, velocity. Yeah? You talk to normal people velocity, acceleration, so on. And the question asks you velocity and acceleration. So write A, T equal to alpha R, and you're referring to wheel B and not A. Some of you confused when this one come out in the exam, you will go and do A. Don't confuse between the object. The question asks you point P is on the wheel B. Substitute the known answer. Alpha B from the previous one, 0.75. R is from the diagram. So AT equal to 0.3 meter per second square. This is in linear acceleration. You convert angular acceleration back into linear acceleration. Same. Normal direction equal to v squared over rho, or you can straight away memorize an equal to omega square r. Omega square, refer back to omega b, 2.659. R refer to the diagram. And remember, this is square. So press your calculator properly here. So some of you will miss out the square there. Okay, answer is 2.8 something. Unit is meter square, meter over second square. Once you have tangent normal, you need to do the trigonometry analysis. You need to find the resultant from the diagram. So resultant is square, tangent, square, normal, square root. Yeah. The question asks you acceleration. This is actually the resultant, not ask you. Of course, the part of the answer step is you need to find tangent and normal. But the final answer don't stop here. You need to find the resultant of the acceleration, which is square AT and square AN and square root. Okay. This is the final answer expected from this question. You need to do square AT square AN square root. Answer is 2.84. Okay. Okay. So so we are now on the already complete. So recall what we learned today. Planar motion, you have two types, translation and rotation. Translation, you have two. One is linear, one is curlinear. You have two motion. Rotation, and then you combine translation and rotation, you get general plane motion. Now we look into general plane motion. Before this, we do rotation, we do translation. Now we combine the two motion and we see what is the difference of analysis. Okay, so this one you already know lah. I already know. So I'll explain something like this. Application of general plane is what you see on the machine here, where there's a piston, push something, and then the object rotate something. This one is, you go and read, just an application of angular motion. We go into absolute motion analysis, copy this one. You need to recall cosine rules. Because of the triangular is no longer 90 degree. Okay, previous example is 90 degree. That's why you can use trigonometry rules. But if the angle is not 90 degree or more or less than 90 degree, you need to use cosine rules, which is S equal to square root A square plus B square minus 2AB cos theta. We have a short break here. The term is according side by side to the diagram. S is the distance between B and C. A is here. A is between the A and B. B is between A and C. The angle is between CAB. So, yeah. Okay, so this one, we have two objects here. The cam is rotating on the O here. Yeah, it rotates like this. And then the spring is moving in the linear form. There are two objects, two motion. So this cam is moved in the rotation motion. And you are given some parameter there. OR, RA, and AO. You are given an angle, positive, you see the arrow there. Positive angle of the cam there is positive and clockwise. And you are given unknown or parameter. There's no value there. You need to derive equation. So you are given the alpha and omega of the cam. So you just imagine when you rotate the cam to the right hand side, the pin, because it's a spring, if you move the cam to the right, the cam will push to the right. So this rod here is a linear motion. It's in the right towards the right, positive. So it's moving in this linear direction. So the rod you can write in the A or V term. Velocity, acceleration, like what you learned in chapter 1 to 3. It's a linear motion. But for the cam, it's not linear, it's an angular motion. So you need to combine linear and angular motion together. Okay, so this will be the thing. You need to determine the velocity and acceleration of the rod here. How you know is by this triangular rotation. You are focusing on A, B, O, this triangular. Okay, You try to imagine, you rotate this triangular, you rotate clockwise, C will become longer, R and A will become same lah, but okay. So coordinate this one. This one is the motion, it's the motion. So I already explained the cam rotation. The pin or the rod is linear motion, rectilinear motion. So we start to write some formula from the triangular. OC, OC, OC and CB is the same length because the R is same side triangular. When you have same side triangular and you have a straight line here, you have the same half length of CB and CO. Okay, so this is a triangular. You dissect the triangular, you cut into half, you get OC was same as CB, and you are using the R as your parameter. So if you convert the R cross theta, you get the length of OC. So the X is 2OC. So we have 2R cos theta. Okay, chapter 5, you try to focus on the R and theta. You convert what you know from the diagram into R and theta. So you find your X. Yeah. So your X is the linear distance. X equal to R. Okay, time derivative, you need to use chain rules of calculus. So you know V equal to dx dt. We are trying to find the speed of this change of this length x here. Okay, V equal to dx dt, but your x is in two parameter or x and y, or u and v. You have u and v, so you need to use chain rules. So I just straight away give you this one. So dx dt at the end you'll get something like this. I skip the chain rules step already. Straight away we arrive this one, minus 2r, because cos you differentiate, you get minus sine theta. Okay, minus 2r sine d theta dt. So your v will equal to these terms. D theta dt is omega. Yeah, d theta dt is omega. So you put in omega in front in the formula. So you get minus 2r omega bracket sine theta. Yeah. So if you don't know how to come from x equal to 2r cos theta to dx dt, later you put in Gemini or ChatGPT or any AI, ask to show you the steps how to arrive at this. Okay. So acceleration also same, dv dt. So dv dt also same. You have two unknown here. R is fixed. So omega is changed, theta is changed. So you do the chain rules again. Do the chain rule again. R is constant. So 2r is constant. You have the u and v here. So you actually differentiating the u and v. Chain rules again. It's a lengthy process. So you get minus 2r bracket d omega dt sine theta minus 2r omega sine theta d theta. Change the d omega dt as alpha. d theta dt as omega. So you have omega, omega, you have omega square. So we have derived the formula, yeah? You can factor the 2r and put side by side. You can factor the r there. Then you have minus 2r bracket alpha sine theta plus r omega square cos theta. Okay. So this formula is important in robotics. You can put inside here, inside the sensor. So you can control when you rotate the cam and when you extend the horizontal rod there. And you can plot the behavior of velocity and acceleration by this formula. Okay, you arrive at these two. So there's a meaning of negative because you're dealing with vector. So negative side indicate that the v and acceleration are opposite of the direction of x direction. Okay. So positive x is towards left. Okay, next one, you just observe. Just observe because we need to go through this one very fast. So this one is a window, piston window that in most of the houses, you have OB, this one is your window. The arm AB is a piston. So when you want to open the window, you need to change the S here, and there's an angle there. So you're given a cylinder extended at a constant rate, 0.5 meter per second. So this one also in the robotic also. So when you know the extension of this piston, determine the angular velocity and acceleration of window at the instant of 30 degrees. Meaning, if you extend this one with 0.5 meter per second, you can find the angular velocity and acceleration of this window. So this one also important when you come to satellite design, when you want to unfold the solar panel. Right, want to unfold. Or if you do into aircraft design, you want to design the extension of your landing gear. So you need to push the piston at a certain speed, and then your wheel will come out at a certain angular velocity. Okay. So we know that we need to define your angle in theta and also coordinate s. So because we don't have a 90-degree angle here, this example is application of law of cosine that I asked you to learn just now. So just this triangular, if you forget. So this triangular is ABC, and then the small one is opposite the capital A is A, opposite the capital B is B, opposite the point C is C. Capital ABC is the angle. The small ABC is the length of the triangular. So the general formula for cosine rules or law of cosine is c squared equal to a squared plus b squared minus 2ab cos c. Okay. So if we copy this triangular, OAB, this triangular, C is the angle. C is the angle. So you convert S square, C is this one. Okay. So you can convert the C square, C replaced by the S from the diagram. A is your OB, or sorry, OA. OB square OB is your B, okay? So this is A, this is B, or it's the same, actually it's the same, either A or B. Minus 2 AB, so A is OA, B is OB, cos theta. Theta is your C. Yeah. So you just translate the law of cosine according to the diagram. You substitute, you substitute. So OA is 5. Not OA is 5, but you substitute, you arrive at one equation. There's something wrong in my answer here. A, I don't know is what, so you need to find. Okay. So here is 5 minus 4 cos theta. So you have the theta of 30 degree. So you press calculator, screw it. There's a typo error in my slide here. It's either 1 or something, but the working step is like this. Okay, time derivative. Because the question asks us to find angular velocity and acceleration. So you see it as a linear equation. And if you ds squared dt means you time differentiate one time. Like this, so there's a chain rule here. There's a chain rule here. So dv squared, if you use chain rules, you arrive at d dt v squared, you get 2v dt, you get 2va. Why a? Because velocity, dv dt, you get acceleration. I think something wrong with my step here. Okay. Something wrong with my writing this one. Okay, never mind. So you substitute value, omega equal to this one. Yeah, okay. So this step to this step, you refer to these chain rules on my slides. This step to here, you refer to this formula. Okay. Okay, you have very long this one. Okay, the rest you read from my slides. It's a lengthy mathematics steps there. But I won't ask you this kind of question in your test or finance. Omega is 0.62 radian per second square. All right. I won't ask you this one, this kind of question, unless if this one come out, I will let you know lah. Usually I don't ask this kind of question. Okay. But this one you will see in mechanics, other subject. Okay, we continue this one in next week lah.